So I have a very basic initial character setup, which will allow me to move the character. I have also started to create environmental props for this character to interact with, although I haven't really done anything for the interaction yet, so I will still need to do a lot of work in order to get this character to interact with the environment properly. But apart from that, I also want to work on interaction with other characters. I want to work on the interactions for NPCs at the same time that I work on the character itself, as one of the main things that I do want to work on with this is the combat system. And working on the animation system for the NPCs as well as the main character at the same time is usually a good idea. There will be a lot of differences in these systems, but there will be a lot of overlaps. And if I do not work on these overlaps early on, it could lead to a lot more work later. So to be able to work with other characters, I'm going to need to start working on the AI system. There are a lot of options when creating an AI system, but all AI systems will first fundamentally rely on one thing, and that will be the navigation. There are a number of approaches which we can take to navigation, but for the moment I'm going to use the default navigation system within Unity. This is still a monobehavior based system, so I am going to be working with managed entities. I will, however, begin by setting up a pure monobehavior. The base system revolves around creation of navigation meshes, and the navigation is performed using the A-star algorithm. To use this, I want to make sure that the package is installed, so I'll open the package manager. The package that I'm looking for here is AI Navigation, and this will give us the basis of the navigation system. And I'm going to create a specific test scene for this. I'll call this Test NavMesh. I'll add a sky and fog volume to the scene. To work with the NavMesh, I will need a terrain, and I'll add this with my terrain HDA. For testing, I'll use the geometry terrain. This is an HDA, and I'm going to add the terrain to this, although that's not generally the best practice. The NavMesh will be added as a component, and the type of the component will be NavMesh Surface. I've added this to the HDA, but this is not where this should be added. There will be two game objects beneath the HDA. The second of these is our generated geometry, and this is where I should add my NavMesh. So I'll remove the component from the HDA. For a release version, I could actually bake out the geometry here specifically. Essentially, we can bake this out as a game object, but this isn't really necessary yet. So now I should be able to add a NavMesh to the scene, and we should then be able to work on this NavMesh. However, before we do this, we should have a basic understanding of how the NavMesh actually works. So currently we have our player, and in terms of our basic physics, we can think of the player as essentially being a capsule. We can simplify this collision to be a collision radius, which will give us a cylinder instead. And for collisions between characters, we'll generally work with the cylinder radius, so we can think of character collisions as being cylinders. This, however, is not how the character is defined within a NavMesh. Within a NavMesh, the character is defined as a single point. We'll generally define this point using the root bone. Essentially, the position of the root bone and the position of this point will usually be the same. We'll then have our scene geometry, and we'll be generating the NavMesh off this geometry. The NavMesh itself is literally geometry, and it is possible for us to construct this NavMesh manually, where we construct geometry specifically for this purpose. But generally, we'll construct a NavMesh based off existing geometry, as this will usually give us a good enough NavMesh. The NavMesh will be constructed on this geometry, but it will also take into account other pieces of geometry. So in this case, we could add a box to the center of the scene, and the NavMesh would need to take the position of this box into account. What will happen now is the NavMesh will be generating a mesh which is offset from the main mesh, and this offset will be the radius of the character. So for the main calculation of the movement, the radius of the character is not going to be calculated. Instead, the NavMesh will be offset, and it will be offset by the radius of the character. So the distance of the NavMesh to other objects within the scene will be the same as the radius of the agent. So for example, the NavMesh would generate around this box, and the width of this offset will be the same as the radius for the character. The point that defines the position of the character should never pass beyond the NavMesh. So this offset is actually defining the radius of the character, and we're not calculating the radius of the character at any point. This will apply to the edge of the NavMesh as well. Every edge will be offset by the radius of the character, so we're not dynamically calculating an offset based off the width of the character. Instead, we are offsetting the edge of our NavMesh. And this gives us a mesh where the mesh compensates for the radius of the character, which means that the distance from the character to the environment should never actually need to be calculated. We can now add this to our geometry, and we can take a look at the component. With the component, we will have a representation of the cylinder for the character. This representation will represent more than just the width of the character. It will represent the slope which the character can traverse. Above a certain angle, we will not generate a nav mesh. There will also be a step height which the character can traverse. And for the cylinder, we can represent a height and a radius for the cylinder. One of the results of this, which we need to take into account, is that this nav mesh will not work with a character which is significantly larger than our own character. So if we have two characters, one which is reasonably small and a character which is significantly larger, the larger character will also have a larger cylinder which will represent its collisions. In this case, we'd actually want to have two nav meshes, one for our standard character and one for the large character. This is a limitation that we do want to take into account. Certain characters will require their own nav meshes, and because the size of the character isn't actually calculated directly, we could have issues when we have characters of vastly different size. This also means that we should always consider having character sizes which are in ranges, rather than having freeform sizes for characters, as we do not want to add too many nav meshes to any given scene. On a practical level, we can add multiple nav mesh surfaces to a game object. To specify a different character, we'll add a new agent type. I'll call the agent type test. For this test, I'll give this character a reasonably large radius. Here I'll give the character a radius of 3.5. I can then bake my initial character. This will be for our standard nav mesh, and we should be able to see the nav mesh being offset from the side of the geometry. I can then change the agent type for the second nav mesh, and this will now represent our test agent. I can then bake this nav mesh as well. I now have the second nav mesh shown, and this nav mesh is significantly smaller. This is a reasonably straightforward setup, but generally we would be adding geometry to the scene. So we can do this now, and this will illustrate some of the issues with having these kind of nav meshes, and this is something which will be very important when designing scenes. I'll add a 3D object to the scene. In this case it'll just be a cube. I'll scale this cube to make it a little bit bigger. I'm then going to move this to the corner of my geometry. I can then rebake my initial nav mesh, and we should see that the nav mesh compensates for this geometry. This gives us a space around this cube based off the radius of the character. We can do the same for the second nav mesh surface, so I'll bake this surface as well. And you'll see that we get a different shaped nav mesh for the larger character, and this will have a much larger space around the cube. But we should note that this geometry is not complete, and there's actually a gap in the nav mesh here. This is potentially problematic. If this is a fight, the larger character may get stuck. It may also not be able to reach the smaller character, so this would be an area where the fight could possibly be cheesed or broken. So this is more complex than just creating a nav mesh. This is where the AI influences the level design, and it's something that we should be very careful of when creating levels. I will remove the second component here as I do not really need it. So I have created my nav mesh, and next I want my NPC. I'll add an empty game object as a parent for the NPC, and then I'll add all of my geometry beneath this. In this case, I'll start by adding a cylinder. This game object will have the name NavMeshTest for the moment. The cylinder will be a child of this. I'll place this at the center of the world. By default, the cylinder should have a height of 2, so I'll raise the cylinder by 1 in the y-axis. This should place the base of the cylinder at 0 in the local space of this NavMesh agent. I can now begin working with scripts for the NavMesh, so I'll create a folder for this, and the folder will be called NavMesh. And this will be created under my scripts folders. I'll start with an empty C# script. I'll call this script test NavMesh. This is going to be a managed script, so it's going to be a monobehavior. When I add this to the cylinder though, we'll see that we do get an error. And that's because as a base script, this is no longer being specified as a monobehavior by default. So I will need to edit the script. Before I do that, I'm going to update my game object with a NavMesh component. And this component will be NavMesh agent. Defining this as an agent will mean that this will be a character which will move based off the NavMesh. I can now edit my script. This class will need to inherit from monobehavior. I'll need a reference to the NavMesh agent component. The type of this will be NavMesh agent, and it will have the variable agent. I will need to include the AI library, although this is being done for me automatically. Next, I'll need to create the awake method. This is an operation which will be performed before the Unity scene is running, at the time in which it is initially loaded. And here I want to reference the NavMesh component on my geometry. This will be stored in my agent variable. Here I'll use the getComponent method, and I'll specify the type as navMeshAgent. I now have a reference to the navmesh component. Next I'll have the update method, and this is what will be called every single frame. Here I will update the navmesh agent, and I'm going to update the agent's destination. This will be done using the setDestination method. The argument here will be a vector3, so I'll specify this with new vector3. Here I'll give this a random destination, in this case 9 in X and 3 in Z. I can save the script and we should now be able to test this. The script can now be added to my navmesh test game object. I should now be able to test the scene, and when I press play, my navmesh agent should move. I can make this a little bit more flexible, so I'll return to my script. I'll make the vector3 value editable within the editor, so I'll create a new variable, and this will be a vector3. This variable will be called destination. The setDestination method can then be updated, and we'll now have our destination as the argument. In order to make the destination visible in the editor, I'll add an attribute here. This will be done between square braces, and the attribute will be serialized field. I should now have a destination vector in my script. I can run the script, and I should now be able to set my destination vector manually. And when I change the values for this destination script, my character will move to different locations. I can now move my character around, but I want to do this with entities rather than strictly using mono behaviors, and I'll be looking at that next.